Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. Here are the three given column vectors, S1, S2, and S3. We'll combine them to form B. The task: compute B equals 3 times S1 plus 4 times S2 plus 5 times S3. Rewrite that as Sx equals B, and then compute the row dot products that give B's entries. Think about it. Can you figure it out before we proceed? You may pause for a moment to ponder. If not, you'll feel good learning it soon. First, we form the linear combination and compute each entry of B by adding the corresponding components. The first entry is 3 times the first component of S1 plus the others. That gives 3. The second entry adds 3 and 4 to give 7. The third entry adds all 3 coefficients to get 12. Putting those entries together gives B equals the column vector with entries 3, 7, 12. Next, we express the same linear combination as a matrix times a coefficient vector, following Strang's observation that a matrix times X is a linear combination of its columns. Let S be the matrix whose columns are S1, S2, S3, and let X collect the coefficients 3, 4, 5. Multiplying S by X reproduces the linear combination and yields B. Remember, each column of S is one of the S vectors, and X's entries are the coefficients we used. Finally, we see Sx as 3 dot products. Each row of S dotted with X gives one entry of B. Row 1 of S dotted with X picks out the first entry, 3. Row 2 sums the first 2 entries of X to give 7. Row 3 sums all 3 entries of X and yields 12. Those 3 dot products are exactly the entries of B, confirming Sx equals B. Quick recap of what we did. Step 1. Compute the linear combination to get B equals 3, 7, 12. Step 2. Assemble S from the columns S1 to S3 and X from the coefficients. Sx reproduces B. Step 3. Each row dot X gives one entry of B, confirming the matrix vector product viewpoint. Nice work. Stay curious and watch the next video to learn more. We promise it's fun. It's fun.